Alright guys, now I would like to explain and compare the method of indefinite interpolation by substitution. I mean here firstly we have the forms of ax to e plus b to the n power, and then we are going to use the first application formula of the integration of the forms ax plus b to the n power, which is the application formula is already written here as 1 over a times n plus 1 times ax plus b to the n plus 1 plus c. So this is actually the formula of integration, right? Alright, so this one actually we can simplify as ax plus b to the n plus 1 over a n plus 1 plus c, right? So we can apply this formula for the example below, and then after that we can compare by use substitution that I will explain also after I finish using this formula. Okay, so please listen carefully. Let's solve number 1 or number a here. The integration of 2x plus minus 3 to the 4th power dx. So if we apply this, it will be very easy. So we just write 2x minus 3, 4 plus 1, and then 2 here, it will be like a here, right? So it will be 2, 4 plus 1 plus c. Okay, so if we simplify, so it will be 2x minus 3 to the 5th power over 2 times 5 plus c. Alright, so in the end we will get 2x minus 3 to the 5th over 10 plus c. Okay, so this is for A. Now how about for B? So again for B, since the function in fraction, so we can firstly change this form into power rows. So it will be 20, right, times 1 minus 4x to the minus 6 dx. Alright, so you have to change first into power rows. So after that we can apply this. The difference between A and B here, we have 20 right here. Now this 20 actually it's just like constant, so we can just put in front of the calculation. Okay, so we just put 20 in front of it, and then integrals of 1 minus 4x to the minus 6 dx, like this. Okay, now after that you can continue to integrate this using the formula, this formula. Okay, so this one will be 20, the integration like this, yeah. So you just write 1 minus 4x. So the a would be minus 4 to the minus 6 plus 1. You can make it longer like this. And then a is minus 4 here, so it's minus 4 minus 6 plus 1 plus c. Alright, so if we calculate, this one is 20 times 1 over minus 4x minus 6 plus 1 is minus 5, and this one it will be minus 4 times minus 5, it will be 20, okay, plus 5. Now we have 20 here, so we can simply cancel it. So it remain only 1 minus 4x in the parenthesis to the minus 5 plus, it's not plus 5, it's plus c, sorry, c. Alright, so if we want to make it positive power, so you just 1 over 1 minus 4x to the 5th plus c, like this. Okay, so it seems still simple here if we apply this formula. So it's just simple like that. Now let's see for the last. See here, this one again you need to change into what is integrals of 5 square root of 2x plus 7. It actually is half here, the power of half, so 2x plus 7 to the minus half, right? Okay, so in integration you need to change all into power rows, so that's why it will be easier to use the formula of integration. Now it is like b, so we can take 5 out or just put it in front of, and then we can use the formula, that one. So a will be 2, so it's right like this. Okay, it's 2x plus 7 minus to the minus half plus 1, and it's 2 minus half plus 1 plus c. It is right. Now this one, this will be 5 2x plus 7 minus half plus 1 is half, and that one of course 2 times half, so equals 1 in the end, right? So it will be 5 only, because 5 divided by 1 is 5, is 2x plus 7 to the half plus c. Or if you want to make it radical or third, so it will be 2x plus 7 plus c. Alright, so this is how we can solve this example using this formula. Alright, now as I mentioned before, we can compare it by using use substitution or by substitution. Alright, let's see how it works. For a first, integrals of 2x minus 3 to the 4 dx. Right, so in substitution you need to substitute by letter, yeah, so it's commonly using u. So this one, if you are using u, so let's say u, let u equals 2x minus 3, so it will be what here? It will be du equals, if we differentiate to x minus 3, so it will be 2 dx, right? So here, since you in this integration we have only dx, so dx will be equal du over 2, right? Now, so see here, this one is u and this is du over 2. Okay. After that, we can change this into that I read before, integration of u du over 2, or half of, we can taking out half, u du. So here it will be half of u du, actually is u to the power of 2 over 2 plus c. So as you can see here, u to the 4, I'm sorry, I forgot it, to 4 and to the 4, so that one it will be 5, I'm sorry, it is 5 and this is 5. After that we can multiply the denominator by 2, so it will be 10 plus c. Yeah, so in the end we have u is 2x minus 3 to the 5th over 10 plus c. Alright, so this is how we can compare, yeah, by using the direct formula or by use substitution. So you may choose any method actually to solve this. Alright, so it's up to you to use the direct formula like this or by using UDU like this. Alright, so for next it's B. How about if the same B we can change by 20, I'm sorry, 1 minus 4x and then minus 6 dx, right, like this, and then let u equals 1 minus 4x, then du it will be minus 4 dx, right? The differentiation of 1 minus 4x is minus 4 dx. Since here we have 20 dx, 20 dx, so in order to make 20 dx, so we have to manipulate du here, yeah. So how to make this be 20 dx? So we can multiply by minus 5, right? So it will be minus 5 du. It will be minus 5 times minus 4 dx, right? So it will be minus 5 du equals 20 dx. Alright, okay. Now here we can change as integration of u to the minus 6. What here we have minus 5 du. Okay, minus 5 is can be constant, so we may take it in front of the integration. So in the end we have minus 5, and the integration of u to the minus 6 du, it should be u minus 6 plus 1, it will be minus 5 over minus 5 plus c. Alright, so here minus 5 over minus 5 is 1, so it's only u to the fifth minus 5 plus c. Or u here is 1 minus 4x to the minus 5 plus c. Or if you want to make it positive, it will be 1 over 1 minus 4x to the fifth plus c. Okay. Again, it's up to you. You may use the direct formula like this, or you can using u substitution. But it's up to you, yeah. Another example, how we perform this by substitution. So here we have the first integrals of 2x times x squared plus 9 to the 8th power dx. And if you see here, if by substitution, you have here in the parentheses, we have x squared plus 9. And then if you notice, if you differentiate this x squared plus 9, it will be 2x, right? So let this be u and 2x dx be du. Okay, so you can rearrange this one, be like this, maybe integrals of x squared plus 9 to the h power 2x dx. Nah, and then u will be x squared plus 9, and then du will be 2x dx. So here is u, yeah, it's u, sorry, and then it's du. So here will be integrals of u to the 8th du, and then it will be u to the 9th over 9 plus c. Okay, so in the end we have x squared plus 9 to the 9 power over 9 plus c. Okay, and then how for this, the next example we have the integration of x times x squared plus 2 close parenthesis of to the third power dx. As you can see here, if you differentiate x squared plus 2, so it will be 2x, right? But here we have x. Can we use the same technique? Of course. First, maybe we can rearrange, rearrange this integration as x squared plus 2 cube x dx, right? And then let u be x squared plus 2, and then du will be 2x dx, right? Now here, since the question only x dx, so to make it to make it x dx, or this one to make it x dx, so we can divide du by 2, right? So if you divide du by 2, so it will be x dx only. Now after that, you can rewrite this as integration of u cube du over 2. Now du over 2, it's constant. It means it's like du times half. So you can take half in front of integral. So it will be u cube du like this. And then it's half. We integrate u to the 4 over 4 plus c. Okay. So half half divided by 4, right? Half divided by 4 is just you multiply half by 1 over 4, so it will be 8, right? So it's u to the 4 8 c. So it will be u here is x squared plus 2 to the 4 over 8 plus c, right? So like this. And how about the next we have here? So again we can do the same technique, because the x squared minus 5 or x, if you differentiate, will be 2x, but here we have 4x. So firstly, maybe we can make it this integral as integrals of 4x times x squared minus 5 squared dx. And then maybe you can rearrange as x squared minus 5 to 4x dx like this. So let u be, okay, let u be x squared minus 5. So du it will be 2x dx. Since in the question we have 4x, so if to manipulate du, so we can multiply by 2, right? So it will be 2 times 2x dx, or 2 du equals 4x dx. Now after that we can calculate here. So it will be integration of u square 4x dx equals 2 du, so it's 2 du, right? Again, 2 is constant, so we can make it in the front of integration u square du. So it will be 2 times u cube over 3 plus c, right? So it will be 2 over 3. U here is x squared minus 5 cube plus c. Okay, so this is the next example, another example how to use substitution. All right, thank you.